what I'd like to do today, it's really interesting. The morning panel started talking about large data sets. It started talking about using data, doing something with it, and the word operationalizing results. And it's interesting, after 18 years of doing this, I'm at the same place. And if we aren't going to use this, the kind of work that I've been doing, then I think our research has been a failure. But I'm hoping today I will show you that we have moved forward. So although we talk about, the title of my talk was oil and gas, and of course that's why I'm here today, but the reality for grizzly bears, the world is not just about oil and gas, it's about the landscape in which they live. There's forestry operations, there's mountain pine beetle outbreaks, there's human activity, all those things occur on grizzly bear habitat. So certainly other activities go on in grizzly bear habitat, and I'm sure everyone's aware of that, but I wanted to sort of state that up front. Over the past decade, a lot of consternation and work in that order has focused around how many bears are there in the province. And a great deal of effort and time has gone into counting bears, and we've done different things on that. They've been undertaken using DNA-based population inventory techniques, and to kind of give you a very simple view, you put out some rotten blood and fish oil in the bush on this elaborate grid cell design shown in those, the picture on the upper right. And a bear is attracted, crosses over barbed wire, and you go and you collect that hair, and from that you do DNA analysis. We did that for many years, coming up with sort of the first population inventory work in the province, which ultimately I think had a big part in having an impact on the status of grizzly bears in Alberta today. So they're now a threatened species. But from 2004 to 2008, we marched up and down the province in different bear management units counting bears. And we did that, and it was the first sort of data estimates that we had. Everything before that was kind of the good old model approach. And unfortunately, the models back then, I called the line to infinity and beyond. It just kept going up no matter what happened. The line just kept going up. That obviously wasn't the case when we started to go in and actually collect data. By the way, just so the people that, just to tie in with management, it took 2 years of data that didn't match what the government thought before the government said, well, you science guys might have something here, and that's when they stopped the hunt in 2006. But it took a couple of years of science before people started to pay attention. So if you think there's immediately response because you've got a research result, yeah, it doesn't usually happen. The picture I've showed here, everything circled in blue represents DNA population estimates from the inventory. And I didn't put in the confidence intervals, but those are really important. The items circled in red are basically still estimates that the government continues to use until they get some inventory work done. I'm happy to say that in 2017, Bear Management Unit 1, the Chinchaga area, will be surveyed. A group up there is doing that, and I'm hoping in 2018, the Swan Hills population unit will be surveyed as well. But the long and short of all the survey information, the number came out much lower than what the government was expecting, and it changed how we viewed bears in this province. The big thing to me that I want to get across today is that we spent over, in 5 years, of $2.4 million in conducting those surveys to get one estimate of N. And that's a pretty big investment, but we got it. We have a starting point. We have base data for that. And beyond that, when we first started, the world has changed. Even 18 years of this project, in the early days, the government would say, we want you to do this, here's the money, please go do it. And in more recent times, we've had forest companies approaching us saying, the data's too old, we need updates, can you do some stuff for us? Industry is starting to think differently, and I'm very pleased with that. So even though we've done this work, and this work still goes on, population inventory work on bears is still challenging, and most importantly, it's still costly. So if people think you can get $50,000 and go out and count bears in a whole population unit, multiply that number by 8 or 9, it's still very expensive. Population estimates for one unit are still in the order of $350,000 to $450,000. It's very expensive work. And even though we have new designs, spatially explicit capture, recapture, people call it seeker approaches that help us do things differently and better, the work is still expensive, and it takes a lot of planning and effort to do that work. So, some good news. I always like to have good news in a talk. So the first population inventory was done in Bear Management Unit 3, though that's the area between Highway 16 and Highway 11, the Nordegg Highway. In 2004, we came up with a population estimate of 36 animals, and you can see the confidence intervals there, 27 to 45. That's a pretty good estimate, pretty tight confidence intervals. 10 years later, we went back, and the population has more than doubled. And with confidence intervals still pretty good. And notice they don't overlap with the previous confidence interval. So that's a good thing for us. But there could be, the confidence intervals of up to 98 bears. That's quite remarkable. It's so remarkable, in fact, that normal rates of population growth for bears in North America is about 3%. This rate of growth on an annual basis is about 7%. So quite remarkable indeed. And think of this. All this occurred with ongoing forestry and mining and oil and gas. The big thing that did change was that we stopped the hunt. And the second thing that happened, we changed habitat. So I can't tell you exactly how all this is going to happen or why it happened. We're doing some more work on that now. Again, population's more than doubled in 10 years and a growth rate of 7%. Now, for those of you who have been around for a while and know the history of bear management and recovery plans and all that stuff, the first recovery plan talked about every 5 years they recommended the government should go back and repeat these inventories to help start to understand population trend. That did not happen for a number of reasons. I think one was certainly the cost of doing these, and the second thing was that there were other priorities within grizzly bear conservation. People want to put money in not just counting bears, but doing other things, which is fair. We waited 10 years to get this done, and the only reason we were able to get it done was that there was a shift in thinking, that the government actually, so the real story was that forest companies came to me and said, could you do about half of this area for us, because we've got some new activities going on. I approached the government saying, hey, what a great deal, because industry's paying for half. If we put in the other half, we could repeat for the first time an inventory. That's what happened. The other bad thing that happened for me, and the people that I work with always say that they're going to slap me if I do this again, Jasper Park heard about this at the same time and said, hey, we've never done the south half of Jasper Park. Come and do that for us too. So I said, sure, that's a good idea. And we did it all at once, and it was a bit of a military exercise, but we got it done. So moving on. So we have to understand population trend. That's one of the things we want to do. So population's increased over 10 years, but remember, 2 points really don't give you a population trend. So you need more information to help with this. And that's where I get in today. So we within the research group wanted to try to figure out if there was a way that we can collect population monitoring data in a cost-effective manner for population recovery to understand how the population's doing. So we wanted to focus on some things a bit differently. We wanted to look at not just numbers, but occupancy, survival, the distribution of animals in the landscape. But we added some new things. One was reproduction, and the other one was monitoring health. And to do all these things, we focused on biological samples. And the biggest thing is we wanted to go to non-invasive approaches. So I've been working for a number of years with colleagues in Scandinavia, and in Scandinavia they have a program they hunt bears in Scandinavia, by the way, and they've recovered their brown bear population, same as our grizzly bear population, brown bears. And the way they do their inventory there, they go out and they ask hunting groups in their state, and hunting groups there have specific land units where they go and they actually are able to go and ask those hunting clubs to go and collect grizzly bear scats prior to their moose hunt. Once they turn in their scat collection, which we get DNA from, the government then gives them their moose tags. If you don't turn in your samples for bears, you don't get your moose tags, and you're very unhappy hunters. So it's a bit of a different social system there. So we wanted to use the same approach in Alberta, because in North America, a lot of things that we do with inventory and wildlife, a lot focuses on hair and DNA extraction. In Europe, just about everything is done through scats, and they use scat samples to get the genetic information. So we did work in 2004, which was our first big year in doing this. We know that scats can be easily obtained by sampling along roads. So obviously in the world of bears, whenever you hear roads and access, you say, oh, that's bad. We did a study in 2014 where we had guys walking, along edges of cut blocks and transects through the bush and all these other things. Hard to find scats there. And then we had other groups that were driving roads and collecting scats, and were quite successful. We know that grizzly bears genetically can be distinguished from black bears through scat, and we worked with the lab in Norway to do all our scat analysis because they were experienced. So we showed that the technique can work. We found scat. We can identify black bear and grizzly bears. We can identify individuals, and some of the results are presented there. So we now have the tools and the ability to do it in a bit different way. And although you still have to pay money to get your scat analyzed, it's a much cheaper approach. So our question really came down to, and we went and we collected all over in 2014 to try to, remember in 2014, that's the same year we did the population inventory work using hair. We came up with the estimate. And then we have this information where we found, for that sample, 19 unique bears were found. 13 were not, were previously identified. We knew about them, and 6 bears we didn't know about on that landscape. And it's about the same as if you had collared individuals as well. So before everybody says, oh great, we've got scat now, we're going to throw away all this other stuff we've been doing with hair because it's too expensive and costly, blah, blah, blah. So what I would recommend is that we do not stop doing DNA hair snag approaches. They have incredible utility, and some of the utility deals with some new things that we've been able to do. So when we first finished our big hair inventory of $2.4 million, in my office I had boxes of this hair stacked up to the ceiling, and it was about when the Sochi Olympics were coming on, and all the medical people were talking about how they're going to monitor and measure drugs and chemicals with athletes, and they were using mostly back then hair. And so that's when we started looking at other things we could do with hair. So before, in the early days of, making me feel old, in the early days we were all excited if we could get the identity of the species, the gender, and recognize individuals from DNA. And now we can do a whole bunch of other things with that hair. So one of the things we've been doing for a number of years is we from that hair sample we collect hair cortisol, measure of long-term stress. And the newest stuff we've been doing looks at reproductive hormone levels. And from the reproductive hormone levels, and we worked with captive bears to validate this in Washington State University, we can identify whether the female is pregnant, we can tell whether she gave birth in the den, and whether she's lactating. Those are all things that we couldn't do before. And if you're a field biologist who works on bears, you said, gee, if I just knew if that bear was pregnant, wouldn't it be nice? But you'd have to catch them, you'd have to take blood samples. But now we have new techniques from that same hair sample to count bears to do many other things. So that's, in my view, part of monitoring and part of what's needed for recovery actions. So back to scat again. So I wanted everybody to understand, don't say we're not going to do hair work anymore, because it's really important. So, of course, there's an app for that in the world of scat collection. So we developed the Grizzly Scat App. Is available on iTunes or wherever. And what you do, instead of, don't send me a garbage bag full of a scat you found in the bush. We have little vials like this. They're full of silica beads. They've got a barcode on them. So if you're driving, think of industry, people are out in the landscape driving these roads. They can stop, pick up a sample of scat. The size of sample you need is about the end of that eraser on the pencil there. That's all you need. Put it in here. You scan it with your phone, scan the barcode, and that data is transmitted to me in my database. I still have to get these vials from you to pick it up, but we can do many other things. So we can use that information to help monitor, and we can do it in a way because when you activate the scat, it tracks your route on the landscape. So I know what areas are being sampled and which aren't. The other thing we've done this year, we want to make sure that, because it's kind of a citizen science kind of thing in a way, we want to make sure that the people that participate get information back. So we send information to them that talks about the fact that we've received your data when you get back in cell service. They then get an email or a text that tells them their sample's been sent to the lab, which we've done now. Your lab analysis is complete and it's bear whatever, and we can also tell them if that bear's been caught other times. and we tell them that it was found by 3 other people. That doesn't mean there's 3 bears. It's the same bear in 3 different places. So there's communication that goes back to people. I think that's really important. So what are we going to do with this? Are we going to do scat collection everywhere, and what are the logistics behind that? Well, we have looked at a bunch of different things. We want to collect scats along roadways both in the spring and the fall, 2 seasons, and that's important. The fall samples, for some reason, have a better extraction rate for the DNA, but the spring, of course, is when a lot of bears are out traveling along and crossing roadways because of snow conditions. We don't have to sample everywhere. We can focus on watershed units where no or few bears have been found. So do you need to go to the areas where you know you have lots of bears? No, but the idea is, think in a population that's recovering, those bears will go out into areas that haven't been occupied. Think of the Yellowstone example. When that area is filled and there's more bears, they start going to peripheral zones. The same thing should, in fact, happen in Alberta with increased populations. We still want to sample in some higher watershed units with higher numbers of bears, and we'll look at occupancy. So we're going to watersheds now that have very low or no occupancy, and we can monitor that over time. So if you think to yourself, well, in the first recovery plan, we said we should go back every 5 years. We did the first one every 10 years. Given you've got a baseline data set and you can now say these watersheds weren't occupied, as occupancy goes up, that might help trigger when you should do your next large-scale population inventory. So this could be like almost sub-monitoring as you move towards a big repeat. And of course you get the sex and individual IDs from bears that you find, and of course the title of my talk was about survival. This information will help you understand survival of bears. It can do other things over time, certainly identify individuals over time, and in long duration of sampling, which is still quite easy to do, you still can start looking at family relatedness. So you can still say, okay, there's a female that's still out there, look, she's got cubs, they're existing and staying on this landscape, and they're surviving over time. So in 2016, you can see all these watersheds that are sort of shaded in red, and there's, I think, 6 of them, 6 in the secondary zone, and then there's 2 in the core that we sampled. What we did, those are the results from the DNA work in 2014. So we went back and sampled for scat in the watersheds that had no or very low numbers of bears found. So we were using this to say, okay, could this technique now be applied in areas where we're concerned about occupancy? And we went and sampled there. We found 73 scats that were collected. And we took a different approach with scat collection this year. We took it more like in the world of transect sampling. You want to go, and the first thing you do in transect sampling for scat, you clear your line, and then you repeat it. In our case, we had field staff that go and drove a route through all these watersheds, and they cleared the line. So no, they removed all the scats. We sampled some of those, but mostly were removed. And then we went back in successive weeks and resampled to see what we were finding. So the samples are now in the lab, and it takes about 4 months to get those samples. I wish it was quicker, but that's the way it is. And they're over in Norway now being analyzed about who those bears are. We can look at survival between 2014 samples and 2016, and we can start looking at occupancy over time. You should understand that although it's pretty cheap and easy to drive roads and pick up scats, there's still a cost for analysis. It's about $100 a sample now. Not cheap, but we're not talking thousands of samples here. We're talking a fairly small number. So here's my pitch. We have a new NSERC CRD project. What I would like to see for the next 3 years, we will have and continue to have collared bears in Bear Management Unit 3 between Highway 16 and Highway 11, this expanding population. I would like to engage some industry people, energy sector and forest companies as well, to see whether we can organize having those people who are out in the landscape already use the apps that we built. We've built the capacity to actually use them, provide the samples, and help us with this kind of approach. This would help, show to the government what the next step should be. It will help monitor recovery efforts and talk about occupancy and survival. So this is a chance to actually use all the things we've invested in an applied setting, which I think is important. So I was asked to put in a slide that says best practices. And this really isn't a best practice, but what I think involvement in this kind of work will do, first of all, it allows employees to participate in conservation actions on a shared landscape. The second thing is that certainly employees and stakeholders can participate at species at risk where you operate, so they're actually involved. They see bears all the time. They probably know, like every spring they see a bear right at this crossing, they know it, and wouldn't it like to be have the information whether it's a male or female, is it surviving, all those kind of things. Do we know anything more about this bear? That's good. And I think importantly we can certainly tie people more to their environment where they work. I think everybody out in the landscape, whatever your job is, you like the idea that you're out in the bush, you see things, you're part of that, and this could engage them. They could be part of a larger program. It's quite easy to do. And certainly, I think one of the big things is this can help the provincial government make decisions about how they're going to repeat these large-scale, expensive survey efforts. I have many people to thank, and I'm sure people know that even though I've been coming here for a number of years, and just let my age out of the bag, sort of, this kind of work would not be possible without long-term research. And I can't thank you folks enough through AUPRF for the ongoing support, because these are the kind of data sets that allow you to answer many questions that we couldn't answer before.